Hello everyone, welcome back for another science video. Today we are going to be learning about Punnett squares and everything that goes into Punnett squares and all of the ins and outs before we get to actually making a Punnett square. So first off, we're going to start off with a little bit of a review from what we learned last time, because I told you guys that everything that we're learning is going to kind of build on itself. So the first thing that we are reviewing is that genes determine traits. Next, we have dominant genes are the stronger gene, and they code for dominant traits. Next, we have recessive genes are the weaker gene, and they code for recessive traits. Hopefully you guys are taking those notes, getting those extra credit points. Alrighty, now we're going to go ahead and get ready to take a look at our dominant and recessive alleles. So you should remember some of this from the last video, but if not, that's okay. So our dominant allele is always going to be a capital letter, and our recessive allele is always going to be a lowercase letter. So I'm just letting you know, these are our alleles. That's how we represent a dominant trait, and that's how we represent a recessive trait. So there are three different allele combos. Three different allele combinations. I was trying to cut it short, but I need to say the whole word. There are three different allele combinations. Let's review them. So the first one is two capital A's. Then we have either a capital A and a lowercase a, or two lowercase a's. So two capital A's means that it's a homozygous trait. The capital and lowercase means that it's a heterozygous trait. And the two lower cases are another homozygous trait. So that just means homozygous means that there's two of the same letter. Heterozygous means that there's one of each letter. Now that we've done a quick review, let's go ahead and take a deeper look into those allele combos. I just kind of told you guys, oh, capital A's equal, this, lowercase equals this, But let's take a little bit of a deeper dive into those combinations so we can get more specific with them. So here I'm just writing out my combinations, capital A, lowercase a, and lowercase a. So we know that this is a homozygous combination because we just talked about it. But we know that it has two capital letters. We know that the capital A means, so we already talked about capital A means dominant trait. So it has two capital A's, two dominant traits. So we would say, or two dominant alleles. So we would say that it is homozygous dominant. So it's not just homozygous, it's homozygous dominant. But then if we look down at the bottom, you say, well, that one is homozygous too, but there's a difference about this one. Let's look at it. There are two lowercase a's. Now, what does the lowercase a mean? Let's think about it. Lowercase a means that that is a recessive allele. So when you have two recessive alleles, and we already know it's homozygous, this is going to be homozygous recessive, since we have two of the same recessive alleles. But then what about where we have, this heterozygous one? What does that mean? So with heterozygous, that means you have one of each, one capital, one lowercase. And when something is heterozygous, we just simply leave it at it's heterozygous. We don't say heterozygous dominant, heterozygous recessive. It's just heterozygous. But how do these actually relate to us? You know, we're talking about all these things. What do they actually do, you know, that we can see, that we know about? So now we're going to go ahead and talk about phenotype and genotype a little bit. So phenotype is the physical appearance of an organism. That's what you actually see on the outside. You having brown hair or brown eyes or curly hair or having, I don't know, dimples or anything like that. That's physical. You can see that with your eyes on the outside. Genotype, that's the actual genes that you have. So those are the actual genes that determine what those traits are going to be. You can't see those. You would have to, you know, get your genetic code and go through a whole bunch of stuff. Okay, that's just on a typical day, you wouldn't be able to see that. It's just looking at your genes. So let's look at phenotypes, which I'm just realizing that I misspelled. Miss Waits needs to slow down with her writing. But there should be a P between the Y and the E. So I wrote our dominant and recessive phenotypes, but guys, what I should have written, that there are dominant and recessive genes that cause different phenotypes. So there are dominant and recessive genes that cause different phenotypes. So we're going to go ahead and look at the genotype that causes the phenotype brown eyes, and we're going to look at the genotype that causes the phenotype blue eyes. I know that's a lot, but you know, if you need to slow the video down or always ask me questions. So if you have brown eyes, you can either be big B or big B little b. If you are big B little b, that means that your phenotype, you have brown eyes, but you carry the recessive trait for blue eyes, so it doesn't show, but like it's like in the background, like you carry the trait to maybe potentially have an offspring with blue eyes one day. If you have blue eyes, you are little b little b. That's your only option. It's nothing else. Let's look at some other examples. So let's say that we want to look at what it would be for dimples or no dimples. So having dimples is dominant, so you'd either be big D or big D little d. If you have no dimples, you are little d, which is your only option. And then we're going to do one more. So let's say that we have attached earlobes versus free earlobes. So that just means like, are your earlobes attached to your face, or are they kind of like, you know, more floppy and free? So if you have attached earlobes, you're going to either be big E or big E little e. But if you have free earlobes, that's recessive. So your only option is little e little e. So let's look at what actually constructing a Punnett square is about. So Punnett squares show the chances of an offspring getting a specific trait. That's how we can kind of draw it out and see it and go, oh, what are the chances, you know, that this offspring will have this trait? It's a visual for us. So, and we normally look at this in percents. So it'll either be 0%, 25% chance, 50% chance, 75% chance, or a 100% chance. I'm going to draw out a Punnett square so that you guys can see kind of how to make sense of that. So a Punnett square has 4 boxes. Each box represents 25%. So 25, 25, 25, 25. If you add them all up, it is 100%. So here we're going to do some Punnett square examples together. So at the top, I'm going to have the genotype of the mom. And on the side, I'm going to have the genotype of dad. Go ahead and draw my line so that my Punnett square is complete. So let's say we want to know right now what the chances of an offspring having brown eyes is. So we're going to say that mom is big B, little b, and that dad is big B, big B. So you're going to put each letter, match it up with the box that it belongs to. So for the box over to the far side, you kind of want to draw a line or go down just to kind of match them up. It's easier if you guys watch what I'm doing, if honestly, rather than me just explaining it and kind of pausing the screen and taking a look at it, because it can get kind of confusing. So at the end of me drawing this, if you look at all of the boxes, each one has a big B. That's a dominant trait. That means that there's a 100% chance that that offspring is going to have brown eyes. Now we're still going to look at brown eyes, but I'm going to go ahead and switch it up this time. So let's say that mom is little b, and dad is big B, little b. Go ahead and match up your letters within your box. Watch what I'm doing so that you can know how to do it too. Watch what I'm doing. You're just dragging the letters over. Drag letters over. And watch this too while you're doing your assignment. So if we look at all of the boxes, now let's see what our chance is. So we just have 2 big B's. That's it. That's 2 out of 4. 2 divided by 4 is going to be 50% chance. So there's only a 50% chance now that the organism is going to have brown eyes. Let's try it with something else. Let's look at what's the chances of someone having dimples. So let's say that mom is big D, and dad is little d, little d. Again, go ahead and make those connections. Watch what I'm doing. Let's see, we have one box. We have 2 boxes we know are dominant. We have 3 boxes that we know are dominant. And now we have 4 boxes that we know are dominant. So what does that mean? 4 out of 4. That means that there is a 100% chance that the kid or the offspring will have dimples. But you see how everyone has a little d? That means that those kids, while they show having dimples, they carry the trait to potentially produce an offspring that does not have dimples. So they will have dimples, but they carry the trait to have a child maybe one day that won't have dimples. Thank you guys so much for watching. Please let me know if you have any questions, and I will see you in the next video.